Okay, thanks. Thank you. I'm very happy to be here. I will be talking about modernization, but not from the technical point of view, but from the point of view of stakeholders that often make the decisions whether the project will be modernized or not.
Isn't that the hardest bit, actually?
Yeah, exactly. Um, So my name is Thomas Hersek. Recently, I have finished a book about modernizing .NET web applications, and during writing the book, I found that this topic could be very useful because developers often know what are the advantages of the new .NET, and they know the reasons why to move from .NET Framework to .NET 9 or .NET 8, the newest versions. However, it's very difficult to explain that to people who don't have that deep technical background. They will probably still have some, but not very deep. So this session should give you some hints or ideas how to make arguments or how to advocate for the need of modernization. I would split that in three categories. First is that you should think and you should describe what are the risks of modernizations and what are the benefits. In the second stage, you should manage the expectations of all people involved in the project because modernization projects are very complicated. Every modernization project is unique. So there is no silver bullet, no single strategy that would work for all scenarios. And the third phase is once you start performing the modernization, you should clearly communicate what is the progress and make sure that everybody involved has all the information for decision making. So basically, when I speak about the risks of benefits, I often start with security because it's a very sensitive topic in many companies. And there's a lot of points where you can explain what are the risks of running a legacy .NET Framework applications. Before I start to digging into this, I should mention that .NET Framework is a component of Windows. It is still supported, and the vulnerabilities in .NET Framework itself will be fixed during like normal standard process of like updating, same as in other Microsoft products. But the problem is most legacy applications, they use third-party libraries, and they can get also security vulnerabilities. And in old projects, I have often seen that like the libraries are not updated to their new versions. Also, some libraries even stopped supporting .NET Framework, so you may end using a library which is not maintained anymore. It probably has some security issues, but you cannot even upgrade it because like either new versions don't exist or they are not available for old .NET Framework. Another point is that .NET Framework apps often use old authentication methods like forms authentication, which is based on storing the information about the user in a secure way in cookies. However, it doesn't support modern features and modern requirements like two-factor authentication or things like that. Some applications still are integrated with on-premise Active Directory, and many companies already moved to the cloud version of it to Microsoft Entra. So the applications should probably, from the security perspective, it would be better if they use the new modern ways of authentication with Entra ID instead of this on-premises Windows authentication. Also, if your application stores information about users itself, for example, using the old APIs such as membership providers or ASP.NET Identity 1 or 2, then if you look at how the passwords are stored in the database, it is not recommended to do like that anymore because, like today, recommendations require stronger hashing than what these libraries use. So this is another security risk that you may face. If you remember how web config files work, there was thing like a web config transformation. Like today, it's a trend not to put the secrets in your code base. Do not commit secrets in Git. There are tools that make sure that secrets cannot be committed to the source control unintentionally. But in the times of all .NET framework, this was quite problematic to use. So I have seen a lot of legacy applications that had secrets everywhere in the code base, in the configuration. And if you looked how to do it safely, how to do it properly, you found that on .NET Framework, it really wasn't easy to do, because today we have technologies like user secrets. You can use Azure Key Vault or things like that, but it's not very straightforward in these legacy applications. So this is another security practice that is typically not followed in old applications. Some old frameworks like ASP.NET Web Forms were not that safe by design. To make things safe was, of course, possible, but the way was more complicated than do it unsafe. My favorite example, and this is a bit technical detail, but you can use it to demonstrate the principle. For example, if you want to print some code in some user value in the HTML, doing it the first way, it's not that secure because the value is not HTML encoded. So it's a potential cross-site scripting injection place. And do it with the encoding requires to write extra character here. And you can easily forget about that and unintentionally paste some value that may not be encoded. Modern frameworks since Razor, I think that they all have the opposite principle, that it's easier and recommended to do it the safe way. And if you want something that may be potentially unsafe, it requires some extra effort. It requires to be explicit about that. Yes, I know that I want to inject some raw HTML, and I'm aware of all the consequences that can be done. The last is .NET Framework heavily relies on the machine key. It's a single secret stored in the machine config file. It can be overridden for an entire application. And if this key somehow leaks out, it's a big disaster because it will affect almost everything, because a lot of things are based on the security of machine key. This is a single point of failure. So again, the new versions of .NET don't suffer from this issue. There are other differences in terms of cost. For example, the old .NET framework was Windows only, which can be a problem if you want to run the application in containers, because the Windows containers are quite heavy. Also, if your company has the bring your own device policy, that's great. But if the developer decides I want to build my applications on Mac or on Linux, like with .NET Framework, it's not very easy. It's not very straightforward. There are nice case studies, for example, from the Bing team that were published, and they migrated from .NET Framework 4.7 to .NET Core 2.1, which is quite old version. But they saw 34% improvement in the overall performance of the application. And because Bing is probably using a lot of servers, they can get rid of some of them. So these are quite impressive improvements. And later, a few years ago, they published another study which says that they saved additional 40% by moving to .NET 6. So these case studies, and you can find more studies like that, showing that the performance is a big game changer in terms of this modernization story. So this can be quite strong argument, especially if your application requires a lot of servers. These can be significant cost saving. Another problem is that not only the .NET framework, but a lot of libraries, a lot of concepts in these legacy applications were designed as monolithic. And this, again, hurts the modernization, because you have to modernize or upgrade everything as a single unit. It's very difficult to change just individual parts. There were also a lot of things, for example, configuration logging. They didn't even have the common interface in .NET Framework, but in .NET Core, it's much easier to build the applications from ready-made blocks. And if you need to modernize again, or if you want to stay up to date, you can change just like a single block at a time, because everything has some base interfaces in the platform. And there are hundreds of tiny obstacles when you work with 15 years old applications, because tooling doesn't count for these scenarios. And each of these obstacles, it's not a big deal, but it can take 1 minute, 2 minutes. And if you have like dozens of these issues every day, it can sum to a significant time needed when dealing with old projects. Like, for example, imagine that the build is like twice longer on .NET Framework than on the new .NET, because like the tooling is better for the new versions. And like how many times you build your app every day, like 100 times maybe. So like the savings can be quite impressive. And my favorite one is developer satisfaction and hiring, because I'm running a software consulting company, and we are hiring developers quite often. And because .NET Core was released in 2016, which is 8 years ago, it's not that new anymore. It's quite a lot, 8 years in our industry. And for example, we are hiring a lot of people who graduated from the university just in the recent years, and they didn't even meet the old .NET framework. They started already learning .NET with the new branch of .NET. So this can be increasingly difficult to find developers who have this legacy knowledge of the technologies which are still supported, but they are not used in the new projects so much. Also, when I'm explaining the hired people what projects they will work on, and we still are running some all .NET Framework projects in my company, I'm almost like feel the need to apologize to people. Oh, really? I'm sorry. We have this like 15 years old project and we need help on that. So like we will not be using the newest and greatest things. We have to use the old things from the long-term strategy. Of course, this is not very attractive for developers because they want to stay and keep their knowledge up to date with the current versions. So from the long-term perspective, people will tend to work on the new things. They will want to experiment. And of course, every company should aspire for having people who want to learn new things, who want to grow. And it's quite difficult to grow when you have to work with a project where you cannot use many of the new features. So like this can be increasingly difficult over time to find developers with the skill set and the willingness to work on legacy applications. And also, if you, for example, look at the Visual Studio release notes, for each update of Visual Studio, they publish a release notes. If you look there, there's a lot of improvements, like building, compiling projects is faster. But in many of these items, you will see it works only in the new .NET project. So a lot of improvements are only for the new branch of .NET, and the tooling, the gap between the like comfort when working on the old project and the new project, the gap is still bigger and bigger, and it will be increasing over time. So these are the problems and also benefits, because if you modernize, you will get rid of these risks. So the second block is managing expectations, and it's important to be very clear about that. Every application uses a unique set of libraries, tools, and approaches. So every modernization project is unique. Often it can be your first modernization project. So there will be a lot of unknowns, a lot of unexpected things, because you just don't have experience with that if this modernization project will be your first. So it's natural that like there are significant risks also when you want to do the modernization. So there are a couple of strategies you may use, and you should first evaluate and experiment and make some like tests maybe, or some like discussions which strategy you want to go with. Some companies decide to basically stop modernizing the old code base. Instead, they start a new project from scratch. They can. This gives a lot of freedom because you can use different libraries, frameworks. You can use a different architecture. A lot of legacy applications were CRUD based, so like basically just a user interface on top of the database, where you can insert, update, delete, and select things. Uh, However, if the processes around the data entities are more complex, you may want to use domain-driven design, for example. So if you decide to do a total rewrite, this will allow you much more flexibility, more changes. On the other hand, it's much harder to reuse existing code. Sometimes you don't want to reuse old code because it's written not the greatest, not the best way, and sometimes you don't even understand the logic behind the code, why it is doing these things, because the know-how got lost somewhere sometime in the past. But there are a lot of old projects which are following the clean code practices. And if the new architecture is very different, or if we are moving things from client to server or back, then it's harder to reuse the code. Uh, Often you will need to set up a new team who will be in charge of creating the new version of the application and keep the old team maintaining the current version, because this project can take 1 year, 2 years, something like that. So there will be two teams, and the transfer of know-how from the old team to the new team may also be quite challenging, because there will be a lot of logic the people already know in the old team, but the people in the new team, they will have to learn what the application is doing. In terms of the incremental modernization, this is a strategy where you still work on the same code base and you are improving things or modernizing things by tiny blocks or tiny pieces. It can be like rewriting pages from, for example, ASP.NET Web Forms to Blazor, or migrating per feature, migrating per any other small block of functionality that you will use, for example, API endpoints and things like that. You are quite limited in making larger changes because still you are within one context, within one code base, and a lot of features have to stay there in the application until you uh, migrate the last piece. Yeah, because there's still the last piece that is not migrated, that it still depends on some other things like logging configuration. So you have to uh, keep a lot of foundational concepts in the project till the very end. On the other hand, uh, like you can reuse quite a lot of percentage of the code, and even if the code needs some changes, most of the time it will be just trivial changes like some one liners, because the API slightly changed, things are in different namespaces, or like they get the async suffix or whatever things like that. So this also allows you to take a safer approach, because you can give the users an option to try the new features. But if something doesn't work, they can have the way of using the old version of the implementation. You can use feature toggles. You can make A/B testing in some cases. Of course, it adds some complexity, but if you prepare for that, it can be a very useful approach. I would say that I cannot say some golden rule whether total rewrite is better than incremental modernization. It depends, and a lot is related to how different the new version should be. If you just want to extend the lifespan of the application and move it to new technologies without making significant changes, then the incremental modernization will be probably easier. If you feel this is an opportunity to make some bigger change, to lay out the application in a totally different way, then the total rewrite will probably work much better. Or you can combine these two approaches, of course. If you choose the incremental modernization, it is possible to make some estimates based on classification. For example, I had seen several ASP.NET Web Forms or MVC applications, and when we made the estimates, we counted how many pages and components we have there and try to assign them into buckets by their complexity. For example, we choose small, medium, and large buckets, and we counted how many pages are trivial, medium, complex, or very complex pages. And then you can either make an estimate for each bucket, or you can make an experiment. The same approach can be used for APIs, for WCF. You can count how many endpoints you have, how complex the input-output models are. In the entity framework, you can count how many link queries you have on your DB context object, how many times you reference lazy loaded property, because this will be the place where some behavior between these two versions of the library can change significantly. And for example, there are some constant items where you will not count the items, but you will make an estimate for the entire migration. Yeah. And once you have this classification, you can count, for example, in this table, I have 16 small pages, 39 medium, and 18 large pages. And I made an experiment. I tried to migrate 3 of each kind. And there were some entity framework queries, and I migrated just like 5 of them. And I used some software for tracking the time, and I really put some effort in tracking how much time I spent on each activity. And based on that, you can extrapolate these numbers. These numbers are for these 3 or 5 items, and you can extrapolate them to the total effort. Of course, this is not everything. There will be other parts you will have to change, upgrade the libraries, change the project to the new SDK and things like that. There are updating the pipelines, for example, updating the configuration logging. These are constant items. You can make an estimate as usual and add these numbers to that. But this can give you some guidance. And you can see that this experiment can be taken within like a scope of like a few weeks. So you can significantly decrease the risk because you will have at least some information. And when explaining this to non-technical stakeholders, try to prepare something that I call a business plan. It can be a document, presentation, whatever suits the needs. And it should include, in my experience, it's good to include these items: the risks of not doing the modernization. If the project stays like that, what risks we will be facing in 2-3 years. Try to explain the benefits, and not only the financial, also the non-financial benefits. You can, of course, the financial, you can calculate how many servers we potentially save, how lower the operating costs would be, how many wasted developer hours we have now, and how it can be in the future. But the non-financial benefits, for example, the developer team will be happier, there will be less friction and things like that. It's hard to assign a price to that, but I think these things should also be communicated, because from the long-term perspective, they are very important, and every person who manages the project or the department should be aware of these things as well. Then you can include the effort estimate. Of course, it's an estimate. It is never accurate, especially in the modernization projects, which are very unique. So these are just the first rough numbers, and like the total final amount may be very different from this one, but still it's better to have at least some idea than nothing. And also, to be fair and to be balanced, you should also include the risks of doing the modernization, because these are very complex projects. There are several unknown things, several complications that you don't expect, and they are likely to happen. So there is a risk of introducing some breaking changes, in introducing new bugs and things like that. The team will need to learn the new things, for example. This is also a risk, because you don't know how much this will take, and things like that. And try to explain or lay out how the process would look like, because I think that predictability is the key to success. If all people involved will know how it will look like, what risks we are facing, why we do that, and have at least some idea of how costly it will be, then the situation is much more clearer for everyone. And the last thing, if you if you manage to get this approved, if you convince based on this business plan, if you convince that the modernization will be going, explain and communicate. It's the two key things, because I have seen many times that predictability is much more useful than delivering exactly on the schedule. If you know in advance that the deadline will not be met, then it's better to like communicate it in advance, because for a lot of projects, especially the internal ones, the deadlines are just fictional. They have to be somewhere, otherwise people would not have any motivation to like look at that. But a lot of deadlines can be actually moved, but the key is to be predictable. The key is to know that in advance. And I I'm used to update these estimates I showed in the previous table, to update it, for example, after every sprint, because they will get more and more accurate. You can project the trend lines and you will see if you are meeting the estimate or if you need to adjust it somehow. Of course, when you see that it's getting off the track, that there are some significant differences from the estimate, I recommend to stop and brainstorm with the entire team what is going on, where we see the complications. Is it just temporary, or we are finding a new unexpected challenges that we will have to solve, and things like that. And one of the last tips, I heard several times the developers saying, I will not waste my time doing some report. We are not meeting the schedule. We are not meeting the deadline. So I will rather spend these 8 hours by working on the actual project, doing the actual work. But in many cases, these 8 hours of a single person, they will not save the situation. Still, the deadline will not be met, and people who are involved in the project, the stakeholders, will not be informed. So I think, of course, you cannot spend all your time making reports, but typically if you have the data, making the report doesn't take that long. It doesn't have to be like fancy polished. It can be just a simple Excel table, Excel sheet, but still it's better to communicate. In my experience, it always proved that it's a better strategy than like trying to do as much work as possible, but not telling anyone what you are actually doing. If you want to learn more about the modernization, here is the link to the book. It's more about technical things. There is all frameworks and libraries that were commonly used in the world of .NET framework, and what are their alternatives and equivalents on the new .NET. So if you are interested in the technical things, you can use this book, and I hope that these points or ideas I presented were useful.